All right, then. Thank you. Hello, everyone. Thank you for joining us today. My name is Yogesh Verma. I'm a systems engineer at Intel, and along with me is Anil Agrawal, who is a hardware systems engineer at Meta. I'm one of the co-leads for the hardware fault management subproject, and Anil is one of the founding members of the subproject. So we'll be giving you an update on our activities today. So this subproject is an incubation subproject of hardware management project. This was announced officially in last year's global summit, which was in the middle of pandemic and went virtual. But despite that, in the short duration since then, we have managed to get together a large number of key participants in the error handling, at scale error handling scenario. Some of those include Microsoft, Google, Intel, Meta, HP, Dell, and others. And there's a plethora of activity going on. Project meets every Friday. So, and we have a link to the wiki here, which has a lot of information and all the documents, and also the past updates that we gave on the activities. So moving on, the charter of this subproject is to address pain points in managing hardware faults at scale. So although the goal is common, there are a lot of variations. For example, based on the deployment, the use cases, you may have different error handling agents in the system. You may or may not want to give control to the host OS, depending on what kind of deployment it is, if it's a bare metal. You may also have different kind of severity associated with the errors of the same nature, depending on what redundancy you may have available. So because of all those variances and differences, to create a common solution for this problem, we felt it's necessary that we come up with a common definition-based, a taxonomy, if you would, of the fault and fault handling. So that includes classification of the errors, the reporting methods, and also provide a comprehensive set of scalable methods that can be adapted to various use cases. So with that goal in mind, we also thought it's imperative that we, instead of providing another new set of standards, we work with a huge install base of the legacy industry standards, for example, UFI, Redfish, and OpenBMC, ACPI, and among others. So with that backdrop, I want to just present a little bit of a more detail here in this pictorial. So our approach here is basically to collect the pain points which were given by all these various participants, who, by the way, cover a vast majority of at-scale data center install base. And then we categorize these pain points on different vectors, such as availability or uptime, performance impact of the error, fault diagnostic and validation coverage. And then that leads us naturally to defining and developing this common taxonomy, where we define hardware fault classification, error reporting formats, interfaces for capturing and escalating the errors and handling them. And also, we propose enhancements to the existing standards to accommodate this common solution. And finally, we also create a shared knowledge base of case studies and best practices in error handling using this common universal taxonomy that we developed, and which includes all these pen points and common classification and the error format, reporting format. So with that, I hand it over to my colleague Anil here, who would go a little bit more into details of the documents and deliverables that our sub-project is working on.
Thank you, Yogesh. Thank you for those who are joining remotely. I know we are getting toward the end, so thanks for staying around. So Yogesh talked about some of the work that we have done and we are currently doing. And in the table in the top, we are showing links also to the documents and the activities that is currently undergoing. First of all is pain point, right? So when we started working on this hardware fault management area, one thing that we observed is that a lot of design and solutions are very in silo, like everybody has their own solution. And it's not at all open as such. So how do we create this ecosystem and open up and share the hardware fault management, architecture, design, validation? The way we started was, okay, let's start listing the pain points. We know in the hyperscale, in the cloud domain, there are some shared problems, and the solution also has to be shared, should be shared. So the first thing we started doing was listing the pain points. And that's what this, the first document is. And after that, we started looking into the error classification. Because error classification itself is a upper debate. Everybody has their own way of defining the errors. So let's come to some sort of a common ground. And then error reporting mechanisms. There is no one single standard, right? And it's very hard to even define as one single standard. So what should be the right way to report the error so that the error information can be scaled across the large cloud, whether it's a completely like a software service, full integrated stack kind of hyperscale deployment, or could be a public cloud where bare metal or infrastructure as a service type of model where the cloud service provider may not own the operating system. So now in that case, all that information need to really flow through the out of band. So how do we define that, the format and share the information? So that's all we have been doing, and there's a lot of work need to be done, and we really encourage all of you to participate, support, help us together in this journey. Now, today we have a few more sessions along the same hardware fault management theme. The next one right after this is memory character error profiling within the large data center. This is something Meta team is going to share, myself and Stephanie and Jonathan. And right after that, there'll be a session on hardware error reporting standardization that we have been working on, and we want to share what we have done so far and where we are going with that. And the last one is a panel discussion. Now, a lot of work has been done in terms of error detection, reporting, so that the machine remains reliable, performant, at scale. But the reality is there are still some areas of gaps or improvements required. And one area is the silent error. How many of you have heard about silent error? Now, that's a pretty painful problem to solve. And so we are learning hard way that even though the design and silicon implementation has a lot of techniques to correct the error, detect error, correct errors, but there is still some room to improve. And we want to share in the panel what are the challenges what are the things that we are observing, and what are we asking the industry to innovate and help us reduce the silent error issues. So that's our game plan. Now, we are not stopping there, right? A lot of work has been done, and we continue to do that, and we are going to share some more results that we have come across so far. Moving forward, what our game plan is that as we are looking at in this sub-project, a platform-centric view, a kind of bottoms up, where how do we design a platform that has a robust fault handling implementation? And how do we validate so that when in the hyperscale cloud space, when we get these racks and racks of machines, seamlessly it can be deployed with the similar kind of performance over and over again. So that is something, the bottoms-up approach that we are taking by trying to define the design requirements, validation requirements, integration requirements. Now, in contrast to that, those who were here on day 0, there is a new technology initiative called Cloud Services Management, which is a top-down approach. And so that actually aligns very well with what we are doing, and we will continue to collaborate. So that's our moving forward direction, to collaborate with various other groups within OCP, so that we all have the same shared problem, and then we can work towards the shared solution also.
So one last call to action is we invite you all to join the conversation. We meet every Friday. It's a lot of activity. All the key players are there, and we are discussing very exciting topics about how to handle faults and how to develop a common infrastructure for that. So please join us on Friday meetings and share your thoughts by reviewing documents or proposals offline. We're also reaching out to, like Anil mentioned, other OCP communities to collaborate, so we can synergize and prevent reinvention of the wheel, kind of. So yeah, links are here. We are available. You can reach to us by email or anyway. So